Welcome to Algebra 1. All right, so this is our first video in algebra. So we are going to cover two lessons today, lesson 1 and 2 in this video. And my goal is to try to keep this under 15 minutes. So we won't do all of them, all of the problems, but we'll do a few good examples, and then I'll have you complete some on your own to bring to class with. All right, here we go. So algebra is the core, algebra at its core is all about using properties of numbers, okay? How they behave to manipulate unknowns, which are variables. Algebra is used to recognize patterns. Okay, that's going to be a big thing this year, noticing patterns. Turn them into mathematical relationships, and then use these relationships to solve useful, to put them for useful purposes. So today's lesson, being the first one, let's take a look at rates or ratios. So in this first one, it says answer the following rate ratio question using multiplication and division. Show your calculation and keep track of your units. Okay, that's going to be a key piece of information. So that's being very careful on how you read things. So this first one, it says if there are 12 eggs per carton, then how many eggs do we have in 5 cartons? So that one's a pretty simple multiplication type of problem. But if we think about it, sort of what our brain is doing, you automatically know, oh, it's 12 times 5, and you're able to get the answer. So we'd say, but if we break that down a little bit and say we have 12 eggs in 1 carton, so we're trying to find out how many eggs are in 5 cartons. So we've got a proportion there, and what do we do with proportions? We cross multiply, so we'd end up with x is equal to 60 eggs. I'm going to have you do letter B and bring it to class done. We're going to take a look at C. It says if a pizza contains 8 slices and there are 4 people eating, how many slices are there per person? So again, that's something that you absolutely can think about, and you say, okay, well, I'm going to divide, and there's going to be 2 slices per person. So mathematically, what is our brain doing? 8 slices divided by 4 people, and then we could continue on with that proportion and say, okay, x to 1, and we cross multiply, and we end up with x is 2 slices per person. Right? I'm going to let you do D, and I'm going to give you a little warning on D. Okay, be real careful about your units right here, this piece and that piece. So be real careful. So come with B and D, done to class. You are also going to do all of exercise 1, so that has parts A, B, and C. You need to fill in the chart in part A, and then answer the 2 questions in B and C. So go ahead and flip the page, and let's take a look. It says, the previous exercise showed how we can take a pattern. Well, we didn't do the previous exercise, but it says, and extend it into the world of algebra. So that's what we're going to do. A world that contains symbols and conventions that may seem strange, but hopefully somewhat familiar from previous work. So let's look for some patterns here. We've got this problem. It says, a man walking across a 300-foot long field at the same time his daughter is walking towards him from the opposite direction. So we've got the father going this way, the daughter going this way. The man is walking at 9 feet per second, and the daughter is moving at 6 feet per second. How many seconds will it take for them to meet somewhere in the middle? Okay. So it says draw a diagram to help keep track of where the man and the daughter are after 1, 2, 3 seconds, etc. Create a table as well. So we're just going to go with creating this table, and we may do some thinking about the other seconds that are not listed here. We may just talk them through. So at 1 second, that information came right from the problem. At 1 second, the father has traveled 9 feet, and then the daughter, okay, her distance, she has traveled 6 feet. Okay, like I said, that information came straight from the problem, and then it says the total distance, so their total distance is 15 feet. So let's just work down here. We'll work down the father's column. So then after 2 seconds, So if 1 second is, or excuse me, yeah, 1 second is 9 feet. At 2 seconds, we're going to be at 18 feet. 3 seconds, which is not listed here, but then that would be 27. You start to see a pattern emerge. At 4 seconds, okay, hopefully you're saying, oh, it's at 36. Now at 5 seconds, it's going to be at 45 feet. So what's happening? We're just taking the number of seconds and multiplying it by 9. So that's how fast that the father is moving. Okay, so the father's distance. So then if I were to extend this chart and I said, okay, well, what about after 15 seconds? So 15 times 9, he's traveled 135 feet. And I'm going to continue to extend it and say, all right, well, what if I go over here to 17? 17 times 9 is going to be 153 feet. And then, I don't know, I might jump up to 20. You'll see why I'm doing this in a second. So 20 times 9, he's traveled 180 feet. All right, so let's go back and take a look at the daughter's distance. So her multiplier, we've got to multiply by 6. So 2 times 6, she's moving at a little slower rate than her father is. 5 times 6 is 30. At 10 seconds, 10 times 6 is 60. Jumping up to 15. 15 times 6, we're at 90. 17 times 6, we're at 102. And then 20 times 6, we're at 120 feet. So let's go through and add these up. And now keep in mind what it said here in the beginning. It says they're walking across a 300-foot long field. So we want to be able to determine, it says how many seconds will it take them to meet somewhere in the middle. That last sentence in the problem is where the question was. Okay, what we are eventually getting at. So to meet somewhere in the middle. So they would have had to have traveled a total of 300 feet. So adding these up, we end up with 30, and then 75, 150, 225. Remember, we're adding the father and the daughter's distance. We're at 255. And then finally, after 20 seconds, we end up with a total of 300 feet. So it says, so how long did it take? Okay, how many seconds will it take them to meet somewhere in the middle? 20 seconds, because their total distance had to add up to 300. It says, what must be true about the distances the two have traveled when they meet somewhere in the middle? State any observations that you think are relevant to modeling this problem. So they have to total 300 feet in order for them to meet somewhere in the middle. And then their distances won't be equal because the father is moving faster than the daughter, or the daughter is moving slower than the father. Okay, the distances won't be equal because the father is moving faster. So as you can see from down here in the bottom right of my screen, it's 1:45 on 8/25. So we're all still on summer vacation. So I am filming this right now from home. And I have 2 dogs. They're quiet right now. One never knows when they're going to bark. 2 of my children are not home right now, but my youngest is. So he could come flying in the door at any moment now. So the phone could ring. So there may be times where you'll hear other distractions going on. I'm hoping I can get through the video today without any distractions, but we'll see. Part C says create equations similar to that in exercise 2. Ooh, this will help you with exercise 2 to predict the distance the father has traveled and the distance the daughter has traveled. Well, we were using an equation as we were filling in that chart. So the father, so his distance was equal to 9 times the time. Okay, 9 times the number of seconds. 9 feet times the number of seconds. And the daughter, okay, her equation was distance is equal to 6 feet per second times the number of seconds. Okay. So now it says create and solve an equation to predict the exact amount of time it takes for the father and daughter to meet in the middle. Well, we know when that happened based on our chart up here. They met in the middle after 20 seconds, but this was sort of our model. They want us to now come up with an equation. Well, we have it. Okay, so when does 9t plus 6t, the father's plus the daughter's, when does that equal 300? So combining like terms and dividing by 15, we end up with that number that we came up with in our chart. Okay, so tables are awesome up here to be able to come up with our answers, and sometimes we've got to be able to then generalize and put it into an equation and do some algebra. All right, so let's go ahead and flip over to the next lesson. So you're going to bypass those homework problems because those are what we do in class. And we're going to be at variables and expressions. This is lesson 2. Okay, so it says this is a process. Algebra is a process of using the properties of numbers to manipulate our variables, okay, or changing quantities. These quantities, oh, there it is, are known as variables. I frequently get ahead of myself. Sometimes I can't help it. I just get kind of excited about the math I'm talking about. And are often represented using letters, okay. Big popular one is the X. He's probably the most popular letter that we'll use. When we group or combine numbers together, we get what is known as an expression. Okay, there's a big difference between an expression and an equation. Okay, so it says an expression is any combination of numbers that we know and ones that we don't know. So we could have numbers in there and variables. An expression does not have an equal sign. Okay, so I'm going to put that in here. No equal sign. An expression does not have an equal sign, only an equation. Think about that prefix in the word equation, that EQUA. Okay, that's reserved for the equal sign as an equation, not an expression. All right, we are going to do B, letter B, and F. So it says here to review our order of operations. Well, that is our handy dandy PEMDAS. Okay. Probably heard, please excuse my dear Aunt Sally. All right. For parentheses, exponents, multiplication, division, addition, subtraction. This is one time where I'm asking you to not use the calculator, just for the sake of that we are reviewing order of operations. All right, so you're going to do the ones that I'm not going to do, and you're going to come to class with those done. So let's take a look at letter B. So when I scan this expression, I see I've got subtraction, multiplication, addition, division. So I'm going to tackle those and those first for my order of operations. So I know it's going to be 8 minus, and then 1/2 of 6 is 3, plus, and then I've got to do 24 divided by 6 is 4. And now when I've got this addition and subtraction just left in my expression, I'm going to just go just the way we read from left to right. So 8 minus 3 is 5. 5 plus 4 is 9. Again, you're going to do the ones that I'm not doing. So when I scan this expression here, looks kind of crazy, but I'm definitely going to tackle this division here, this negative 16 divided by 2. And then I'm going to tackle that 5 times 2. Oh, but look at that. That's probably got to be first, is going to be that 2 to the 3rd power. So my 2 to the 3rd power means 2 times itself 3 times, which is 8. 2 times 2 times 2 is 8. Now I'm going to do this division to get negative 8 plus, and then the multiplication is 10. Now I've got to take care of this numerator up here first before I can do the division by 8. So I've got negative 8 plus 10. gives me 2 divided by 8. Now I could say, all right, well, what's 2 divided by 8? If I simplify that, 1/4. I tend to prefer fractions. They're exact. Obviously, 0.25 is equivalent, but I tend to like the fractions. All right, let's hop down to letter C. So you're going to do A and B on your own and come to class with them done. So this one says, if the letter X represents some unknown quantity, explain the calculation that each of the following expressions involving X represents. Okay, so explain the calculation that each of the following expressions involving X represents. So what would I do first here? Okay, so if I'm going to explain it, that means I have to use my words. So what would be my first step here? So this is 4x squared minus 8. X must be squared first. Just the X. That 4 is not being squared. Okay, then what would I do? Okay, then I would multiply, by 4. And now what would my last step be? I would say, and then 8 subtracted from it. Okay? 8 subtracted from that amount. Okay. All right, flip the page. We've got one more to do and we will be done. So evaluating expressions. So finding the result of the calculations of an expression when all variable values are known. So you are going to do A on your own. You are also going to do C in exercise 4. We are going to do B together right now. Evaluate the expression 8 minus 2x squared when x is equal to -3. Show the calculations in the order in which you do them. So if 8 minus 2x squared is my expression, and I've got to find the value of the expression when x is -3, that means substitute -3 in for x. Anytime I do substitution, I put parentheses around the number that I am substituting. I'm going to use red there, okay, as sort of a warning. Get in the habit of doing that. You will avoid mistakes. So let's think about our order of operations. Tells us parentheses, well, nothing to do in the parentheses, but then our exponents, we have to square this. So what is -3 squared? -3 means -3 times -3. Which is a positive 9. Now I have to do my multiplication. 2 times, oops, I need to write that out again. 2 times 9, which is 18. And 8 minus 18 is -10. Okay? So what do we have to do first? We had to square -3. Then we needed to multiply it by 2 and then subtract it from 8. All right? Okay, remember, any of the ones that we did not do together, you are to do to come to class prepared with them done and with questions. I will definitely be calling on people to come up and explain their answers, rate their answers, sort of be the teacher, if you will. All right, thanks, guys.